Section 5.1, Simplifying Rational Expressions, is really the last section that we'll be doing, in which we will be doing a lot of factoring. And it is really just a lot of review of sections 4.1 through 4.6. So let's take a look at an example of a problem that you'll find in section 5.1. If you are given the problem 10x squared divided by 15x to the fourth, you can go through and you can simplify that. First of all, it's called a rational expression because rationals are when numbers are written as fractions, and this is written as a fraction. So if I have 10x squared over 15x to the fourth, if I wanted to, I could break these both up into their factors. 10 would be 5 times 2, and x squared would be times x times x. If I do the same thing with the denominator and break up the 15, I will get 5 times 3 times x times x times x times x. Now if I wanted to, I just need to go through and I can factor out the common terms that are both in the numerator and the denominator because they are equal to 1. So 5 divided by 5 is equal to 1, so those are gone. This x divided by that x, they're gone, that's equal to 1. This x divided by that x, they're gone, they're equal to 1. So I am left on the top with just a 2, and on the bottom I'm left with 3 times x, which I am going to write as 3x squared. So I've simplified the rational expression that I started with. Here's another example. 25w to the sixth over 20w squared. Once again, I'm going to factor both the numerator and the denominator. The numerator could be factored down as 5 times 5, and the denominator, I'm just going to do the whole numbers here for a moment, could be factored down as 5 times 4. Now, I still have a w squared on the bottom, and what I'm going to do is, just to kind of save a little bit of time and space, the top w to the sixth could also be written as w to the second power times w to the fourth power. Certainly, if I wanted to, I could go through and I could do w times w times w times w times w times w. I think I have 6 of them there. But I'm going to rewrite it as that w squared times w to the fourth, which is the same thing. Now, when I go through and I factor things out, 5 divided by 5 is equal to 1, so those are gone. The w squared over w squared, that's equal to 1, so those are gone. So, on the top now, I am left with 5w to the fourth, and on the bottom, I'm just left with 4, which is the factored form of what I started with. Here's another example. Negative 36x to the fifth y to the third over 21x squared y to the fifth. This time, I'm not going to break it up quite as much as I have those first two problems. I'm taking a look at the negative 36 and the 21, and I know that a common factor of 36 and 21 is 3. So I'm just going to go through and I'm going to divide each of those by 3, which means that the coefficients are now a negative 12 and a 7 if I divide both those numbers by 3. Next, I'm going to be taking a look just at my x terms. I have an x to the fifth and x squared. If I wanted to, I could go through x times x times x times x times x is x to the fifth. X squared is x times x. So if I wanted to, I could go through this process and cross out the two x's on the top and on the bottom, leaving me with x to the third. But the easier way is just to go through and subtract the exponents, 5 and 2. So on the top, I'm left with x to the third power. Then when I take a look at my y's, once again, if I wanted to, I could write it out. I have y times y times y over 5y's, y times y times y times y times y. And if I go through and cross out y's, you can see that I'm going to be left with y squared on the bottom. Once again, I'm just taking a look at my exponents, 3 and 5. 5 minus the 3 is 2, but the 2 needs to be on the bottom because the 5 is the bigger number and it is on the bottom. So my final answer in factored form is negative 12 x to the third over 7y squared. Here's another example of a rational expression that we can simplify. 4x subtract 28 over 5x subtract 35. First of all, before I get started, let me make positive sure that you do realize that I cannot go through and cross out the x's in both of these terms. The reason for that is because these are terms. The x's are in terms, and I cannot factor things out if they are just in terms like that. So that's not possible. Instead, I'm going to rewrite what I had. 4x subtract 28 over 5x subtract 35. Now I'm going to go through and I'm going to factor each one of these. If I factor the top, I can factor a 4 out of both of those terms, which leaves me 4 times x minus 7 in parentheses. On the bottom, I'm going to factor out a 5 out of both of the terms, which also leaves me an x subtract 7. Now I have x minus 7 times x minus 7, x minus 7 over x minus 7, and these are factors. So I can factor them out, leaving me with an answer of just 4 over 5, or 4/5. As I mentioned at the beginning of this video, a lot of this is really review of Chapter 4. So I take a look at this, and the very top, 5x minus 10, I can go through and factor out that 5, so I'm going to have x subtract 2. The bottom, x squared minus 4, it's important that you recognize that that is a difference of perfect squares. So, difference of perfect squares, I'm going to go through the reverse of FOIL and have an x and an x, because the square root of x squared is x. The square root of the 4 is equal to 2, so the second term in each side of parentheses is a 2. One of these is add, one of these is subtract. Once again, now I have a common x minus 2 factor in the numerator and in the denominator. So I can factor those out, and I am just left with a final answer of 5 over x plus 2. Here's one that has a trinomial on the top and also a trinomial on the bottom. So I'm going to use the skills that we talked about in section 4, chapter 4, that is, and we are going to factor both of these. If I factor the top, 6x squared subtract x subtract 2, working on factoring that, I could get 3x subtract 2 and 2x plus 1. Now I know I went through that quickly, but that's just a review of chapter 4 material. In the bottom, if I factor that, I'm going to get 3x subtract 2 and x subtract 1. And once again, I know I just wrote down the answers because I did them ahead of time, but that is a review of chapter 4. Notice that I have a common factor of 3x minus 2 in both the numerator and the denominator. So now I'm going to go through, I'm going to cross both of those out, which leaves me a final answer of 2x plus 1 over x minus 1. Here's one that I'd like you to try on your own. You'll turn off the video, please, do it, and then turn the video back on and see how I do it. The only thing that I will mention to you is recognize that the top is a difference of perfect squares, while the bottom is a trinomial. Okay, hopefully you had time to go through and solve this. This is how I would go through and solve this. That top, once again, I mentioned, is a difference of perfect squares. So for the top, I'm going to go through that reverse of the FOIL in a way, but this is an A and an A. And the square root of 9b squared is 3b. So I have 3b as the second term in each one of those sets of parentheses. And one of them has to be an addition, one of those has to be a subtraction, because it is a difference of perfect squares. As I start to work through the bottom, since I know I'm going to have to be factoring this, I'm going to really be taking a long look at what I got on the top, thinking that I'm probably going to get an a plus 3b or an a minus 3b on the bottom as well. When you do go through and factor this, you should end up with a plus 5b and a plus 3b. Now I have a common a plus 3b in both the numerator and in the denominator that I can cross out, leaving me with my final answer of a subtract 3b over a plus 5b. Once again, I want to pay special attention. It's not possible for you to factor out the a in the a here, because these are not factors, these are terms. And you cannot factor out terms, you can only factor out factors. So that final answer, a subtract 3b over a plus 5b. I want to do one more example of simplifying rational expressions with you, but before I do that, I'd like you to take a look at the two problems that I put up here, which does not have any variables, no algebra at all in it, and let's talk about what these answers are. Notice in the first one I have 4 subtract 3 over 3 subtract 4. Same numbers, I just reverse them. If I do that, 4 subtract 3, I'm going to get 1. 3 minus 4, I'm going to get a negative 1. A positive divided by a negative is equal to a negative, so I get a negative 1. For the other one, 10 subtract 8, 10 subtract 8, I get 2. In the bottom, all I did was reverse. 8 subtract 10 gives me a negative 2. Once again, 2 divided by negative 2, I'm going to have an answer of negative 1. Notice I got an answer of negative 1 both times. I have a subtraction problem in both the numerator and the denominator, and all I did was I switched where the numbers were. So using that information, if you're given one like this, 5 subtract y over y minus 5, it doesn't matter what that y is equal to, because I just reversed those. I'm really going to have an answer of negative 1. If I wanted to, I could go through and show that algebraically by just doing a little bit of other work with this. If I have 5 subtract y and I have that y minus 5, I could think of that y minus 5 as a negative 1 times y minus 5 if I multiply that by a negative 1. If I did that, I would get negative y plus 5, which then, if I reversed these, it would be 5 minus y, which is the same thing if I multiplied it by a negative 1. The answer to this is just a negative 1. So I just want to let you know that any time at all that you have something like that, let's say 3 subtract x over x subtract 3, if the numbers or the variables are the same, they're just in the reverse order and it's subtraction, the answer is always going to be a negative 1. As I mentioned to you at the beginning, this section 5.1 is really a review of the information in Chapter 4. I would remind you to take a look at the guidelines to follow when factoring that I handed out and we talked about when we did section 4.5, which will greatly help as you go through and factor the numerators and the denominators, and then work on factoring out common factors. Thank you.